This is section 2.3, Shapley-Shubik power. This is an alternative way to figuring out the power distribution in a weighted voting system. We start with some definitions. Sequential coalition. So coalition is just a group of players. And if if order matters, that means that we're going to be listing here all of the different orders that if there's 4 players, like let's say there's 4 players, we're gonna list all of the players, but in all the different orders that we can line them up. That's the sequential coalitions. A list of all the players in different orders. It has to be all the players. So in 2.2, we listed, coalitions that had only 2 people in them, and then we had coalitions of only 3 people, and then we had the grand coalition. Well, in 2.3, we're going to be listing all 4 players in each coalition. And the only thing that's changing is the order that they're in. Okay. We're kind of thinking about this as people walking into a room, and as they walk into the room, we get their amount of votes. And when that person comes in the room that now and they change it from we were a losing coalition, and now this person walked into the room, and with their new votes, we now are a winning coalition. They call that a pivotal player. So so we're going to be counting the votes from left to right. I imagine the person on the left is like the first person who came in the room. So the second person is the second person to come in the room. And then, like I said, we keep adding the votes from left to right. And one player that adds enough votes to meet the quota, that is the pivotal player. Pivotal count is the number of times that player is the pivotal player. Then the Shapley-Shubik power distribution steps are, you're going to list all of the different orders all the players could line up. For n players, it's actually going to be n factorial. So let me show you what that looks like. So if you're like wondering, well, how many different ways can n players line up? Well, it's actually n factorial. So if there's 4 people that are going to line up, there's 4 factorial different ways that 4 people could stand in a line. The different orders they could stand in a line. So 4 factorial means 4 times 3 times 2 times 1. Okay. So it'd be 4 times 3 is 12 times 2, right, is 12, then multiply by the 2, and then that equals 24, and then times by 1 is still 24. So 4 factorial is equal to 24. So that just helps you make sure that you list all of them, is you can figure out how many there's supposed to be in the very beginning. Okay, so you just list all the different orders that everybody can line up, all the players, they include all the players. Then within each special collision, underline the single pivotal player. I think it's AL. So like I said, I imagine when they're in order, people walking into a room. And once that person walks into a room where now we have enough points to be a winning coalition, that person's the pivotal player. To do this, count votes from left to right. I think the first person plus the next person until you add a number that changes from losing to winning coalition. Then that's your pivotal player. Okay. Then next, the last thing we're going to do is we're going to find the Shapley-Shubik power index for that person. And I'm sorry. Well, I guess we're gonna count the number of times that they're a pivotal player. I guess we're going to count the pivotal count. I guess it's a better way instead of writing all this. Count the pivotal count of each player. And up above, it says the pivotal count is the number of times that player is a pivotal player. And then lastly, really we should add a step 4 here, and that is we're going to be calculating the Shapley-Shubik power index, which is that player's power according to Shapley-Shubik. And the way we're going to do that is we're going to take their pivotal count, which is they denote it SS1 Shapley S for player number 1 and SS2 for player number 2, and so on. You're going to take that number, your pivotal counts, and you divide it by the total number of pivotal counts. I'm sorry, not total number of pivotal counts. No. The total number of sequential collisions there are. Sorry about that. I'm thinking of the other one. So you're going to divide it by n factorial, where n is n is the number of players. Okay, so they call it SS, I believe, P sub 1. That's the Shapley-Shubik power for that player number 1. And then Shapley-Shubik power for player number 2 is their pivotal counts, player number 2's pivotal counts over the number of coalitions, and so on for every player. All right, that's the instructions for how we do this. Let's see an example. He said if normally I would put like if I was in a live classroom, I'd put different names just to make it a little bit more personable for you guys. But player 1 has 5 votes. Player 2 has 3 votes. Player 3 has but player 2 has 3 votes. Player 3 has 2 votes. And player 4 has 1 vote. So this is the same, and they actually do the same. A motion must have 60% of the passage votes. Well, you can go back and watch the 2.2, and you can figure out how we came up with this. But 7 is the number in our quota, and that's because it's 60% of all the total number of votes. And I did that calculation in the previous lecture for 2.2. So you can go back and watch that if you'd like to see that. But this is the same setup as we had in the same example that we did in 2.2, except for we're going to do it differently, this new Shapley-Shubik power distribution. And so it's just a different way of calculating the power of each player. This is the weighted voting the weighted voting system that we're going to be working with. Okay, so what we're going to do here is we're going to list there's 4 players, so we're going to list all the different orders the 4 players could walk in the room, basically. So it could be player number 1, the most obvious, followed by player number 2, followed by player number 3, followed by player number 4. That's the most obvious. Okay, then you could have player number 1 followed by player, and I'm going to do all of them that start with the first 2 players being the same. Player 1 and player 2 are first. Then I could switch who came 3rd and 4th. So then player number 4 followed by player number 3. It's important to try to keep this. And I think I'm going to try to make my line a little bit smaller, so maybe it's a little bit easier for me to write these. All right, and then player number one. Okay, so that's all I can't, if player number one comes first and player number two comes second, the only thing I could do is switch around the last two players. Right? So the next thing I'm going to do is I'm going to do player, I've got to switch around the second player now. So it's still player one comes in the room first, but now let's say player three comes next. And it's just because three is the next number after two. So three comes next. Then what could happen then? I try to always go by order the first. So player three could go, and then player two could come in, then player four. Now I switch the order. So keeping the first two the same, player one and player three could walk in. Then after three, all I can do is switch two and four. So if four came in next and then two came in next. Then player one could come in, and now the only thing, I did all the ones that with player one and player three, player one first and player three second. So now we can go with player four being second, player one being first, player four being second, and then we could do player two and player three. There's one last one with player one first and player four second. And that's if I just switch the last two here, so player three and player two. That's all the coalitions that contain player one. The next, maybe I can go over here so it's a little bit easier. But now, so like let's go over all the ones that start with player two. So two comes in first, one could come in second, then three could come in, and then four could come in. If I keep the first two people the same, then all I can do is switch the last people. So four and three. Then I still keep two, okay, the first person, but now I've listed all the possible combinations that could have two come in the room and one come in second. So now I have to pick somebody else to be second. And I usually, just to keep things a little bit more organized, the next number that's bigger than one and not equal to two is three. So I'm going to go with P3 comes in the room next. And then P1 and then P4. So these are all the only way that if I would keep the first two stagnant, so P2 and P3 stagnant, then all I can do is switch the last two, P1 and P4. Then I have P2, and then I exhausted all the P2 with P3 second, so now I have to pick somebody else to be second. We already picked P1 and P2, P1 and P3, so the next person is P4. Then that leaves P1 and P3 to come in the room. P2 and P4, and then now all I can do is switch the last two. All right, now we can start all the coalitions that start with P3. And I like to start with the ones that P1, and go, notice how I went from 1 to 3 to 4, so as being the second person, so I like to do that. So I list all the ones that have P1, P3 followed by P1. That would be P2 and P4. P3, P1, and now I'm just to switch the last two. That's the only different order that we can have if P3 and P2 are the first people coming in. All right, and so that's, now I have to switch who comes in the room second. So I'm gonna say, let's go with, I already did P1, so I'm gonna go with P2. So P3 and P2 and P4, I just switched the last ones, P4 and P1. Now it's P4, wait, no, P3. We're still, all of this list is P3. Then we exhausted P1 and P2 being in second place. So now we have P4 that has to be in second place. And so P1 and P2. Then P4, sorry, P3, P4, and then P2 and P1. So we're just listing all the different ways that these four players could come in the room like, or stand in line. All right, then the last one is where P4 starts off. And you could like easily fast forward this if you you get it, and but if P4 comes in the room, then P1, P2, and P3 could follow them. Then P4, P1, and then I can switch the last two, so P3 and P2. Now, because I exhausted, P4 is always going to come in the room first for all this whole line. But then I exhausted P1 as being a second person. So now I'll do P2 as a second person. And then that would leave P1 and P3 to come in next. P4 and P2, and then it would be P3 and P1. All I did was switch the last two. Then I could do P4, and now I've exhausted P1 being in second place and P2 being in second place. So now we can use P3 as in second place, or second to come in the room here. So then P1 and P2. And P4, P3, P2, and P1, and there we go. There is all of the different ways that these four players could walk in this room or could stand in a line. Okay. Like I said, you can calculate 4 factorial because there's 4 players. So 4 factorial should be the number of collisions that we listed here. And so that's 4 times 3 times 2 times 1. And like we saw above, that should be 24. And if we count these, there's 1, 2, 3, 4, 5, 6 groups. There's 6 in each group, and there's 4 groups here. So there's 24 different orders that we've listed here. All right. The next thing that I'm going to do is I'm going to start from the left and work my way right. And I'm going to keep adding the weights of each player until we become a winning coalition. Once we become a winning coalition, I underline that person and say that was a pivotal person because it was that person who, when they walked in, they made it a winning coalition. So player 1 is 5 points, plus player 2 is 3 points. So that would be 8, which is bigger than 7. So player 2, when they came in the room, it caused them to have enough points to be. I'm gonna change my color here. It gave them enough points to be a pivotal player. So player 2 was a pivotal player. Because this is the same order, I can say the same thing. I don't have to do the math again. Okay, so player 1 walks in the room with 5. A weight of 5, and player 3 walks in with a weight of 2, so 5 plus 2 is 7. So once player 3 walked in, they had enough points to be a winning coalition. I can do that again for the next one. All right, player 1 is in the room, and then player 4 adds, who has 1 point. So 5 plus 1 is 6. But they still don't have enough points to be a winning coalition. But guess what? 6, all we need is 1 more point. So the next person in the list is going to be the player. I don't even have to add that. I just know because he's going to be more than 1. All of our players are more than 1. So same thing with the next one. Whoever comes in the room next is going to make it a winning collision. Okay, so we already saw that player 1 and 2 together make a winning coalition. So as soon as 1 it adds to 2 or comes in the room, and when 2's already in the room, then this is going to be a winning coalition. Same thing here. Okay, so 2 comes in and they have 3 points, and then player 3 has 2 points. So 3 plus 2 is 5. They still don't have enough points, but they need 2 more points. So player 1 comes with 5 more points. So that's definitely enough points for them to be a winning coalition. 2 and the same thing here. So 2 comes in with 3 points, plus 2 points from player 3 is 5, plus 1 point from player 4. 1 point, so 5 plus 1 is 6. It's still not enough, so player 1 here is the one that's going to make the difference. Okay, wait, so let me just double check that. So player 2 is 3, player 3 is 2. So 3 plus 2 is 5, plus 1 is 6, which still does not make the quota, so they had to wait until player 1 came in the room. All right, so player 2 is 3 points, player 4 is 1 point, so that's 4 points, plus player 1 is 5 points, which makes it enough to be a winning collision. All right, player 2 is 3 points, plus player 4, which is 1 point, so 3 plus 1 is 4. Plus player 3, which is 2, which is 6, which still is not enough, so it's like we need another point from this player. All right, so let me just double check. I'm gonna write the numbers below here this time. Okay, so player 2 has 3 points. Player 4 has 1 point. Player 3 has 2 points. So that's 4 plus 2, which is 6, which is still not enough. So they have to wait until the last person comes in. So that's okay. That's all right. All right, so then we start with player 3. Player 3 has 2 points. Let me just write that, 2 points. And then player 1 has 5 points. That 5 plus 2 is 7, which meets the quota. So player 1 here is pivotal. Should have just left that line. All right, player 3 has 2 points plus, oh, the same thing's gonna happen because it's the same order right there. All right, player 3 comes in, they have 2 points, plus player 2, which has 3 points, but that's 5 together, which is not 7. So they wait for, and then player 1 comes in with 5 points, so that now they have 10 points, which is greater than 7. So they have a winning collision with player 1's addition. So player 1 is pivotal. Okay, player 3 has 2 points, plus player 1 has 3 points, plus player 4 has 1 point. So it's 2 plus 3 is 5, plus 1 is 6, but they still don't have enough, so they have to wait till the last person to come in. Player 3 has 2 points, plus player 4 has 1 point, plus player 1 has 5 points. So you have 3 points with the first two, plus 5 is now above 7. So player 1 is the pivotal player. Player 3 has 2 points. Player 4 has 1 point. That's not enough to be a winning collision because it's just 3. They need 7. Plus player 2 has 3 points. So they now have 6 points, which is still not enough. So they have to wait for player 1 to come in the room. Player 4 has 1 point and player 1 has 5 points. That's not quite enough to be a winning collision. So they wait for, because that's 1 plus 5 is 6, which is less than 7. So they wait for P2 to come in and they have 3. So now they have 6 plus 3, which is 9, which is greater than 7. So with the addition of player 2, they became a winning collision. Player 4 has 1 point, player 1 has 5 points, and that 1 plus 5 is 6, which is not greater than 7, so they need to wait for P3 to come in with 2 points. So 6 plus 2 is now 8, which is bigger than 7, so now player 3 was the one that came in with, helps them win. Player 4 has 1 point, player 2 has 3 points. Player 1 has 5 points. So that's 1 plus 3 is 4, which is less than 7, which is not enough. So they add 4 plus 5 is 9, which is now greater than 7. So P1 here is the pivotal player. P4 has 1 point, P2 has 3 points, P3 has 2 points. So it's 1 plus 3 was 4, which is not greater than 7. So they still need to add 2 more, which is 6, is still not greater than 7. So P1 is the pivotal player. P4 had a 1 point, P3 has 2 points, which is 3 points, so they still have to wait for P1 has 5 points, 5 plus 3 is 8, so P1 is the pivotal player. P4 has 1 point, P3 has 2 points, P2 has 3 points, so that's 3, which is not enough, not bigger than 7, plus another 3, which is not bigger than 7, so P1 is the pivotal player there. So now we have gone through and we figured out the pivotal player in each of these coalitions. Now we count the number of times that each player is a pivotal player. So that's our SS1 is the pivotal counts of player 1. So I go through and I just look for where P1 is underlined. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 times that player 1 was a pivotal player, and then player 2. So it's 1, 2, 3, 4 times. And then player 3, pivotal player, let's see, player 3. So it's 1, 2, 3, 4 times. And then how many times was player 4 a pivotal player? So I think that is 0. I counted 0. I'm gonna make sure I counted this as number 1. So I guess all of these, you could double check, should be back to 24. You add up all these counts just to make sure that you counted all of them. 14 plus 4 would be 18, plus another 4 would be 22. So I think I'm missing 2 of them. I'm gonna just count. I'm gonna count the number of ones for right, because there's a winner in each one, and so every single red line should be equal to the number of coalitions we listed here. So let me count the number of ones again. So there's all of these 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Oh, wait, no, 6, 6. There's 6 here, 6 there. So like, I think that's 12. Then it's 13, 14, 15, 16. I think it's actually 16. I think I missed 2 somehow. Yeah, because there's 1, 2, 3, 4 over there. I think it's actually 16. Okay. All right, and then what we do next is we find the power, we calculate each player's power, and that is by, they denote it by SSP, Shapley Power Index, and sub 1, and that's equal to the Shapley pivotal counts over n factorial. And n factorial we saw at the top, I can scroll up, is 24. So that's going to be 16 over 24. This one, the Shapley power distribution for player 2 is 4 over 24. Shapley for player number 3 is 4/24. And Shapley power distribution for player 4 is 0/24. So then we could do 16 divided by 24 in our calculator. That equals 2 divided by 3, which is 0.6, which is 0.666666, which is also 66 point. Did I do that? I'm wondering, like, oh wait, okay, which is 66%, 0.66. Okay, so I should have put 66.66 because that 6 goes on forever. We could round it to 0.67 because the 6 goes on forever. Which would put a line in front of it to mean that it goes forever, but I'll just put 66.67%. And then this is 4/24. And that's equal to 0.16 with the 6 also going on forever. So it's 16. So moving the decimal twice. I mean, moving the decimal twice to the right and adding a percent symbol, it becomes 16.67 because I just rounded it to the 7 because the 6 goes on forever. The same thing with this one, that's 0.176 or so. I'm rounding it to 67. So that would be 16.67% and then this one is 0 divided by 24, which is 0. So 0% for that last one, which is interestingly, if we go back up and so, oh, and this is the notation, the sigma, that's what, so we could write this down here. So the power for number 1 was 66.67, power Shubik Shapley power for player number 2 was 16.67, and then 16.67 for player number 3, and then 0% for power number 4. And that's the power distribution for the Shapley power distribution. And they like to use this little sigma notation for that, power symbol. Okay, so I wanted to just quickly compare this with the power distribution that we found using the Banzhaf power. So like, if we go up in my notes, which I don't, okay, maybe I didn't. Oh yeah. Okay, we found the first player was 60% and the 2 other players were 20% and the last person was 0%. So they're not often, the Banzhaf power and the Shapley are not normally exactly the same. Because they're calculated a little bit differently, but in general, they're close to each other. You know, this one says 60, that one's 66. So it's in the same ballpark. It's giving you the same feel. All right, I hope you found this valuable and have a great day. Bye.